Today, I'll be showing how I use Blender as a level editor for my personal project, Dribble. This project is not using a game engine, instead I am using Simple Direct Media Layer, or SDL, as a game framework. I've recently finished the bare bones for the game, and now I'm about to start designing levels. Without using an engine, to change an object's position in the level, I'd have to change a hard-coded position, run the game, get to that specific part of the stage in the game, and then see if I like where it's placed. This made visualizing levels difficult, so I decided to use a third-party software as a level editor. Back in college, one of my classes tasked me with making a level renderer using a graphics API. We had to make our own levels in Blender, and the professor provided us with a script that would export the world matrix for the objects in the level to a text file. After a bit of research, I realized how accessible the Blender scripting API really is. Basically, any operation in Blender can be called from the Python API. For most buttons in the editor, if you hover over them with the mouse, then press Ctrl+C, the exact Python function signature will be put in your clipboard. And seeing how I haven't used Python before, this seemed like the perfect opportunity to learn it. I'll give a quick overview of how the system works before stepping into the code. Each in-game object is associated with a tag. In Blender, these tags can be assigned through a drop-down menu. When the user is finished making the level, you can press the export button, which prints out the relevant information about each object to a .level file. The game then reads this file and adds the objects to the level in their correct place. I'll start at the very top of the pipeline. I have a small program that takes every tag and prints them to a text file. Every tag is actually an enum under the hood called a level tag. To make adding enums easier, I set up a macro which creates an enum and a matching getString function which returns the enum name as a string. There is also a getLevelTagValue function which translates the string to a level tag. I found this code from a Stack Overflow post which I'll link in the description. And after building and running the program, this is what my output text file looks like. Then hopping into Blender, reading tags has two parts: the path to the tags file and the reload tags button. We'll step into the Python code for the reload button now. First, I store the tags in a container called valid tags. Then we clear the old list and read all the strings from the level tags file. This buildSet function returns a list of the tags read from the text file. I sort the tags alphabetically before rebuilding the valid tags array. I know I'll be adding a lot of tags later on, so having them sorted makes them easier to find in the editor. Then in this for loop, we append a valid tag array using this tuple. An enum's value requires a tuple where the first three elements are strings. I assign the identifier and the name to be the tag and leave the description blank. In the final for loop, we go through all of the objects in the scene and validate their tags. To explain this tag name property, I was having an issue when adding new tags. Through testing, I realized that only the enum's integer value is actually stored on the object. But for the tags to be in alphabetical order in the UI, they need to be added to the valid tags in order. This wouldn't be a problem normally, but since I'm dynamically creating the enum with the text file, this integer value could change depending on the number of tags. If I were to add a tag between two existing tags, the list would shift and the following tags would be incorrect. As you can see in the diagram, if I were to add a jump pad tag, every object that had the obstacle tag would now have the jump pad tag, and every following tag would be shifted by 1. After some research, I found that if you assign an enum property by its identifier, which is the tag's name in my case, it'll automatically check if that identifier exists. If it does, it will assign it correctly regardless of what the value is. So, in this loop, if the object's old name is empty, we cache the tag's name. If the old name no longer exists, we assign the default value, and if the object already had a valid tag, the tag is assigned according to the old name. And that's the end of the reload tags function. Then once the level is made, I can click export to get the relevant properties like the tag, location, dimensions, etc. I put the name of the property in brackets just for readability, And now that we finally have the level file, it's time for the game to interpret this. I've defined this external entity data struct to store the data from Blender. Then we'll move into my create level function, which opens the file for reading. It repeatedly calls this getEntityData function, which removes the line's name in brackets and then stores the rest of the string in the output string. After all the data is read, we call this createLevelEntity function, which in turn calls a function called makeEntity. This is where the ability to go from a level tag to a string comes into play. After taking in the uniform data, like the dimensions and the asset path, etc., we convert the tag from a string to a level tag enum using this getLevelTagValue function, which was made by the macro in the beginning. Then we'll call this switch statement to create the correct object according to the tag, and that is how every object in the game is made. I'll now demonstrate what this workflow would look like when I create a new game object. I have this dummy class that I'll integrate into the Blender system. All this object does is change the color of whatever object comes in contact with it. So the first step is I'll move over to my leveltags.h file and add the tag to the enum. I'll name it dummy for now. Then I'll build and run the level tag exporter program. And in my text file you can see that the tag has been added. Then we'll step back into Blender, and as a side note, I made my own version of import as mesh plane, so I'll choose the asset. I think the E-tank looks good, and then I'll click import as mesh plane, and I will size and position it how I see fit. And in my drop down menu you can see that the dummy tag isn't there. Then I'll click reload tags and the tag will appear in the list, and once it appears I'll assign it to the object, and once the object has the correct tag and it's in the right place, has the right scale, I'll click export level, and you can see that in the .level file the entity is there. Now we'll go into my makeEntity function and we'll include the dummy's header file. Then we'll go down to the bottom of the switch statement and add the case for the dummy tag, and then we'll create the dummy object, and that is all. And you can see that the object is where it was in the level, and when the player touches it, they turn a shade of blue. You know what? I'm not sure if I like the E-tank. I think I have a better icon in mind. I'll use Mega Man's Extra Life icon. I'll just go into Blender and switch out the assets. I also think it's a little big, so I'll scale it down and move it further from the player. Now all I have to do is click export and run the game. Overall, I'm pretty satisfied with this pipeline. I think I've streamlined it pretty well. I had a lot more ideas for the Blender add-on, just like small quality of life things, but I had to cut myself off because I just kept having ideas and kept working on it, but like other things in the game need to get done, so I had to stop myself. If you'd like to keep up with the game's progress, you can follow the itch.io page or my LinkedIn. I'll put stuff in the description. I make blog posts on itch.io a little more frequently because they are not as hard as doing video editing. This is my first time like really editing a video like this. This took a long time, so but I did like doing it, so I will make more video updates later. But anyway, thank you for watching, and stay tuned.